Who first gazed up at the night sky and wondered about the twinkling lights scattered across the darkness? Our journey begins thousands of years ago with the dawn of astronomy. The stage was set by ancient civilizations whose curiosity about the cosmos inspired them to observe, to question, and to theorize. The foundations of astronomy were built upon their observations and theories, and their contributions still resonate with us today. In the 2nd century, a visionary named Ptolemy emerged. He formulated the geocentric model, a model that placed Earth at the center of the universe. While this view might seem quaint to us now, it was a significant step towards a more systematic understanding of the cosmos. Ptolemy's work, Almagest, became a cornerstone of medieval astronomy, shaping the field for centuries to come. Around the same time, other great minds were also making their mark. Aristarchus, known as the ancient Copernicus, proposed a heliocentric model, placing the sun, not the Earth, at the center of the universe. Though his idea was not widely accepted at the time, it planted a seed that would later bloom into a revolutionary understanding of our solar system. Then there was Hipparchus, another luminary of ancient times. His work provided crucial insights into the motions of celestial bodies. He cataloged stars, developed a system to predict solar eclipses, and is often considered the founder of trigonometry. These pioneers of astronomy, Ptolemy, Aristarchus, and Hipparchus, were the early stargazers who dared to look up and question the nature of the twinkling lights scattered across the darkness. Through their observations and theories, they laid the groundwork for celestial understanding. They began a journey of cosmic discovery that we continue to this day. So as we delve deeper into the history of astronomy and look at the notable astronomers who have shaped this field, let's remember the early pioneers. Their curiosity, their dedication, and their passion for understanding the cosmos set the stage for all that was to come. These pioneers laid the foundations for our understanding of the cosmos. In the 16th century, a man dared to challenge the prevailing view of the universe. This daring figure was none other than Nicholas Copernicus, a Polish mathematician and astronomer. He dared to contest the geocentric model, which argued that the Earth was the center of the universe, a widely accepted belief since the days of Ptolemy. Instead, Copernicus proposed a radical revolutionary model, the heliocentric model. In his vision, the sun, not the Earth, was the center of the universe. The Earth, along with the other planets, revolved around the sun. This shift in perspective wasn't merely a change in celestial coordinates. It was a profound paradigm shift that challenged the very way we perceived our place in the cosmos. The heliocentric model faced fierce opposition, yet it survived, thrived, and eventually became the accepted model in astronomy. Copernicus's heliocentric model set the stage for a new age of astronomical discovery. The path to understanding the universe is not always a straight line, a truth Johannes Kepler knew well. His meticulous observations and mathematical prowess in the early 17th century led to the formulation of Kepler's laws of planetary motion. These 3 laws revolutionized our understanding of the cosmos. First, the law of ellipses, which states that planets move in elliptical orbits with the sun at one focus. This replaced the circular orbits of earlier models, bringing us closer to the truth of celestial dynamics. Next, the law of equal areas, which describes how a line connecting a planet to the sun sweeps out equal areas in equal times. This law revealed the variable speed of planets in their orbits. Finally, the law of harmonies. This law connects the orbital period of a planet to its average distance from the sun, showing the beautiful symmetry of our solar system. Kepler's laws continue to guide our exploration of the cosmos. A new tool, the telescope, would forever change our view of the heavens. In the early 17th century, Galileo Galilei, an Italian astronomer, mathematician, and physicist, pioneered the use of this instrument for celestial observation. With this tool, Galileo brought the heavens closer to us, revealing a universe teeming with wonders previously unknown. He observed the pockmarked surface of the moon, contradicting the prevailing belief that celestial bodies were perfect spheres. Galileo also discovered the 4 largest moons of Jupiter, now known as the Galilean moons, proving that not all celestial bodies revolved around the Earth. His observation of the phases of Venus provided strong evidence for Copernicus's heliocentric model. But perhaps most significantly, Galileo's meticulous observations and records marked the birth of modern observational astronomy, shifting the discipline from philosophical contemplation to empirical science. Galileo's work laid the foundation for modern telescopic astronomy. The laws that govern the motion of the planets are the same that keep us grounded on Earth. In the late 17th century, Sir Isaac Newton revolutionized our understanding of celestial mechanics with his laws of motion and the law of universal gravitation. He presented these laws in his seminal work, Philosophiae Naturalis Principia Mathematica, providing a unified framework for explaining terrestrial and celestial motion. Newton's first law, often known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion, unless acted upon by an external force. His second law established the relationship between force, mass, and acceleration. And his third law, perhaps the most famous, asserts that for every action, there is an equal and opposite reaction. His law of universal gravitation described gravity as a force that acts between all masses in the universe and is inversely proportional to the square of the separation between their centers. Newton's laws continue to shape our understanding of the universe. The first woman to discover a comet, Caroline Herschel, was a trailblazer in more ways than one. Born in the 18th century, Herschel was not just a woman in science, but also a pioneer in the field of cometary astronomy. She dedicated herself to the skies, working closely with her brother William Herschel. Together, they embarked on a celestial journey that would lead to the discovery of numerous celestial objects. Caroline Herschel's meticulous observations and unwavering dedication led her to discover a comet, a feat that etched her name into the annals of astronomical history. But her contributions didn't stop there. Herschel's work provided significant insights into cometary astronomy, helping to expand our understanding of these celestial travelers. She was instrumental in cataloging stars and nebulae, a pursuit that furthered our knowledge of the cosmos. In her lifetime, Herschel discovered 8 comets and cataloged countless celestial bodies, leaving an indelible mark on the field of astronomy. Herschel's work expanded the known boundaries of our solar system. In the early 20th century, one astronomer's observations would radically alter our perception of the universe. This man was Edwin Hubble, whose name is now synonymous with our understanding of the cosmos. Hubble's work was groundbreaking, as he was the first to demonstrate that galaxies were not stationary, but rather, they were moving away from each other. This movement suggested that the universe itself was expanding, a concept that was revolutionary at the time. Hubble's observations led to the formulation of what is now known as Hubble's law. This law states that the speed at which a galaxy is moving away from us is directly proportional to its distance from us. The farther a galaxy is, the faster it is moving away. This discovery was a monumental leap in our understanding of the universe, challenging previous static models and paving the way for the Big Bang theory. Hubble's work forever changed our understanding of the cosmos. Sometimes what we can't see is just as important as what we can. This phrase perfectly encapsulates the pioneering work of Vera Rubin. In the mid-20th century, Rubin turned her gaze toward the stars and made a groundbreaking discovery that continues to baffle scientists to this day. Rubin meticulously studied galaxy rotation curves. In simple terms, she observed how galaxies spin and noticed something peculiar. Galaxies were rotating in such a way that the stars at the edge moved at the same speed as those near the center. According to the laws of physics, this shouldn't be the case. The stars at the edge should move slower. This observation suggested that there must be some unseen matter exerting its gravitational pull, causing the stars to move faster. Rubin's work provided compelling evidence for the existence of this unseen matter, now known as dark matter. Rubin's groundbreaking work continues to shape contemporary research on the elusive dark matter. The journey of astronomical discovery continues, propelled forward by a new generation of visionaries. In the realm of contemporary astronomy, figures like Carl Sagan have made significant strides. Sagan, a pioneer of exobiology and a popularizer of astronomy, has inspired countless individuals to gaze up and wonder about the cosmos. Meanwhile, Neil deGrasse Tyson, with his unique ability to make complex scientific concepts accessible, continues to ignite a passion for space in people of all ages. His work in astrophysics and his role as a science communicator are shaping the way we understand the universe. Space exploration, too, is experiencing a renaissance. With the advent of private space companies, we're seeing an intense interest in exploring and understanding our cosmic neighborhood. The possibility of manned missions to Mars and the search for extraterrestrial life are pushing the boundaries of what we once thought possible. Today's astronomers stand on the shoulders of giants, pushing the boundaries of our cosmic understanding. The story of astronomy is a testament to human curiosity and the desire to understand our place in the universe. This narrative is told through the groundbreaking contributions of visionary astronomers, from Ptolemy's geocentric model to Hubble's expanding universe. Copernicus's heliocentric model shifted our perspective, Kepler's laws refined our understanding of planetary motion, and Galileo transformed observational astronomy with his telescope. Newton unified terrestrial and celestial motion with his laws, while Herschel expanded our solar system's known boundaries. Hubble's observations led to the realization of an expanding universe, and Vera Rubin's work hinted at the elusive dark matter. Today, astronomers like Carl Sagan and Neil deGrasse Tyson continue this legacy, pushing the boundaries of our cosmic understanding and space exploration. As we continue to gaze at the stars, we honor the legacy of these astronomical pioneers who have guided our journey through the cosmos.